Hi, this is Gary Lerude of Microwave Journal. I'm here at the 2018 International Microwave Symposium in Philadelphia with Scott Vasquez of Qorvo. Scott is the Senior Market Manager for 5G products. Scott, thanks for talking with me today.
My pleasure, Gary.
So Qorvo has a pretty broad spectrum in terms of 5G. You cover the low bands as well as millimeter wave. Let's start with the low band. Can you tell us a little bit about the new products you've announced for sub-6 gigahertz?
Of course. So we've released two new gallium nitride products for sub-6 gigahertz. They are two Doherty amplifiers. They have a driver amplifier, and then carrier and peaker amplifiers as well. They are targeting 4.4 to 4.9 gigahertz and 3.4 to 3.6 gigahertz. The advantage with GaN is they put out a great amount of efficiency, about 38% today of efficiency from both devices. So we're very excited for those two parts to tackle 5G sub-6 gigahertz. We also have some receive chain components as well. They're actually modules that combine switches and LNAs for the receive chain. They are dual channel devices as well, and they can handle either 5 or 8 watt incident power levels on the switch. That is the QPB 9329 and QPB 9319. And we've done exceptionally well with those types of products in the market with our customer base. And then finally, we have a driver amplifier, the QPA 9120, which is your run-of-the-mill driver amplifier. However, it has exceptionally high gain and exceptionally high linearity. So we're also excited to introduce that part to our sub-6 gigahertz 5G portfolio as well.
So can we talk a little bit more about the GaN Dohertys? Are these targeted for macro or small cell or maybe massive MIMO?
Right, these are targeted for massive MIMO, so high EIRP levels outside the phased array, sub-6 gigahertz massive MIMO.
And what's the kind of power level that you're getting out of the devices?
So today we're getting, for the higher frequency part, the 4.5 gigahertz part, we're getting 3 watts out of average power. And for the 3.5 gigahertz part, we're getting 8 watts of average power out.
Nice.
And you'll see that as a trend in general is those power levels are going to continue to increase over the next 12 months as we develop new products going forward.
And what kind of market pull are you seeing for the sub-6 gigahertz 5G systems?
It's tremendous, and it's a tremendous market pull, and we believe that the sub-6 gigahertz market is really taking off much sooner than the millimeter wave market. So from a ROI and business case perspective, it's a very exciting time to have those parts available.
Well, let's talk about millimeter wave now. Last year, you announced a 39 gigahertz, pretty impressive GaN front-end module.
Thank you.
What else are you doing in that space these days?
Right, so correct, we announced 39 gigahertz last year. This year, we're working on 28 gigahertz. There are two 28 gigahertz devices in development. They're actually being measured now, so they're going to be available very soon. 1 and 2 watt devices, single channel and dual channel, gallium nitride, integrated PA, integrated LNA, and integrated switch. So a very similar form factor, very similar functionality to the 39 gigahertz devices, which we've had a lot of success with, so we're replicating that for 28 gigahertz.
And remind us, given the proliferation of technology for millimeter wave, there are some companies that are pursuing CMOS-based solutions.
Right.
How did you end up taking a GaN approach?
Right, so there's a lot of pros and cons to different technologies and architectures. There are also a lot of use cases in the 5G world, whether it's a high EIRP base station or a lower EIRP CPE. And so we're really tackling the 5G millimeter wave base station for higher output radiated power. And in that case, when you need, say, 65 dBm of EIRP, if you use some lower power technologies like silicon germanium, you really need a much larger element count for your phased array. 256, 512, 1,000 elements. The reason we chose GaN is because that number all of a sudden becomes much lower to potentially 64 elements or 32 elements because of the inherent output power capabilities of gallium nitride. So we believe that simplicity and the higher efficiency of gallium nitride really provides some distinct advantages for Qorvo in the millimeter wave 5G space.
Interesting. You mentioned that you've seen more market demand for the sub-6 gigahertz. Can you talk a little bit about the kind of market interest you're seeing at millimeter wave frequencies?
Right, so it's interesting because everyone is saying, well, millimeter wave really won't take off until 2020. But a lot of the critical work is happening now. A lot of cycles of learning are happening now, and so even though potentially the large volume production is in 2020 or beyond, There is a lot of work going on today that we're involved in with our customer base, and so it's a critical point in time to be involved in millimeter wave and be involved with our customers to kind of go through the growing pains of this industry and vet all the different things we're trying to vet, whether it's ROI, whether it's technical performance, cost, etc.
Well, Scott, thank you for talking with us. I think this is an exciting time to be a 5G market manager because everything is happening.
It is. Thank you very much, Gary.
Gary Lerude from the International Microwave Symposium in Philadelphia.